But then what comes after that? Each particular covalent drawing has what we call a VSEPR shape attached to it. So what is VSEPR? VSEPR means valence shell electron pair repulsion theory. Ooh, complicated name. But what does it mean? It means that electrons repel other electrons. So even though you got to pair them up, they ultimately don't like each other. So what happens is VSEPR is something that gets created. It's a geometry, it's a shape of a molecule. So every covalent compound has a three-dimensional shape. Okay, it doesn't look like these drawings right here. They are not just flat on a paper, right? They're three-dimensional. And so we give those shapes a name, okay? So once again, a non-metal and a non-metal is what makes a covalent compound, okay? So there are two vocabulary words we need to know in order to create a shape name. The first one is called the central atom. The central atom is the least electronegative atom in the molecule. To think of it simply, you can think about the fewest number of this atom. So basically, if you see like BF3, which element do you see less of? B, then that has to go in the middle, okay? Like H2O, there's 2 hydrogens and 1 oxygen. That means oxygen has to go in the middle. It's a central, we call it the central atom. CF4, there's only 1 carbon, 4 fluorines, so carbon has to go in the central, the center, the middle, okay? Lone pairs are pairs of unshared electrons. So these are the dots of electrons that are not being shared. They do not participate in a bond. They're not being shared, okay? So for example, boron here is where? Here, boron is in the 3rd column, so it has 1, 2, 3. Okay, does it have any lone pairs? Does it have any pairs? So pair means 2 electrons, they're already buddied up, right? There are none here. And you're like, I'm confused, what's a lone pair then? Then let's look at fluorine. Fluorine is in the 7th column, right here. So we'll draw 1 on each side. There's 4, 5, 6, 7. So remember, every time you have a solo electron here, you know they're going to create a friend. But these electrons, like here, here, and here, they already have a pair. They already have a friend. So how many lone pairs are there? Pairs. There are 3 pairs. Whoa, these different. 3 lone pairs. The total of 6 electrons that are not being shared, right? So carbon is where? It's here, it's in the 4th column. So 1, 2, 3, 4. None of these have a buddy, no lone pairs. But oxygen, according to the periodic table, where is oxygen? It's here, number 6. So we're gonna draw 6 dots. 1, 2, 3, 4, 5, 6. So we can see that there's a pair here and a pair here. You know, these electrons are going to get shared out. They're going to share. So how many lone pairs do we have? We have 2 lone pairs. Okay, so central atom, what goes in the middle? Center, right? Lone pairs are electrons that are not being shared. Basically, like the question is, do they have lone pairs? Yes or no? So like here, I would write, this has no lone pairs. Here, the answer is yes. I don't really care about the number. I actually want to know if it's no or yes. Yes, it has lone pairs. This one has no lone pairs. Then over here, you would say, yes, it has lone pairs. The number's not really that important. It's just a matter of no or yes, lone pairs. All right, so there are 5 VSEPR shapes. I'm going to go through them really quick, and then you'll probably learn more about them in class, but let's just go through it. So elements bonded to the central atom. So here you can think of it as 1, and then we're going to put an Na because there is no central atom. So basically it's saying you have an element bonded to another element. So there's nothing in the center, so no central element. The shape then is called linear. Why? Because it creates a single line. Okay, so just like this picture, it creates a single line because one is bonded to another. it automatically creates a line. So if we go back to our previous notes over here, we can find ones that are linear, right? The linear ones are the ones that create a single line. So here, this one is linear. It created a single line. There's no middle or center element, so it has to create a line. This one is also linear. It creates a single line. There is no center element. This one has a center, this one has this one, even though this has a double bond, this is still considered linear because there's nothing in the center, creates a straight line, right? So those are your examples of linear shapes. Okay, the next one is this. Okay, say you do have something in the center, right? That means we have a center and we have two elements bonded to the center, okay? It could be the two of the same elements, right? Lone pairs on the center atom. So if the answer is no, so you look at the center, so this is really important. Does the one in the middle have lone pairs? That's the question. If the answer is no, then it still creates a line. It creates a really long line, but it's still a straight line, okay? I don't think there were any examples up at the top, but hopefully you'll run into one, right? And the next one is like, okay, then what if the center one does have lone pairs? The answer is yes. The one in the middle, not the outsides, but the one in the middle, the center has lone pairs. Yes, then we say that the shape is bent, okay? This is because there are electrons right here, these lone pairs, that push the shared electrons away from them. They're like, can you please go away? Because you're like really annoying. So, so originally it was like a straight line. But if you have lone pairs in the center, then it's like pushes them down. So a straight line then becomes boop, bent, okay? The next one, next couple of shapes on here, right? So third, if there are no lone pairs on the center, we call it trigonal. So think tri meaning three or attached to three, and then gonal, and then we say planar. Planar meaning that it's flat, okay, it's flat. And then there's an example of this up here actually. So here, we see that this boron right here is attached to how many? 3 fluorines. Does boron have any lone pairs? Nope, there's no dots, you know, all the electrons for boron are sharing. That means this is trigonal planar. Okay, so this is an example of a trigonal planar molecule. Okay, if the answer is yes, the one in the center does have a lone pair, it's still called trigonal, but it is going to create some sort of weird pyramid. So we call it pyramidal. Like this, okay? And it's because this lone pair right here pushes down on all the shared bonds and it's like, I need you to go away. So something that was flat now gets bent, okay? Remember the word bent, but now it creates a pyramid because there are 3 of them being bent, okay? So let's see if there's an example up here. I believe there is. Aha. So see this nitrogen right here? It's attached to 3 iodines, but what do you see here? A lone pair. So yes, there's a lone pair. Then what is this shape? This shape is trigonal. And then you would say pyramid, and then the all, pyramidal. So pyramid and then al. The last one is if you're attached to 4 and there are no lone pairs in the center, then it creates a tetra. Remember, tetra means 4. Tetrahedral. Okay. Tetrahedrals are not flat. Remember, 3-dimensional. So tetrahedrals is like this one right here. You see the carbon. It's attached to 4 hydrogens, but there are no lone pairs. No lone pairs. Then that means that this is tetrahedral. Tetra meaning 4, right? Okay, so let me show you some other examples really quick so you can see it. Okay, so just to show you a couple of examples like three-dimensionally. So here you have one attached to another. So you can see the shape down here. It's a linear shape. So you can see that three-dimensionally it looks like this. If I were to add another one like this, you can see that you're attached to two, but when you don't have any lone pairs, like even if you try to like chase them around, it's still a straight line, which is why it's called linear, right? Now, when you add lone pairs, so like electrons that are not shared onto the center, the central atom, then you cause these shared electrons to get bent down. See, now it looks like a little alien, right? So now it looks like this. That's why the shape is called bent, because you literally bent them down. Okay, but if I took off this lone pair and now we're connected to 3, this is the one that was in our example BF3. This is trigonal planar. Do you see how it's flat? So if I were to go like this, you see that it's flat, plane, right? But if I were to add lone pairs to this, that flatness now becomes a what? A pyramid shape. So there you see the pyramid shape like this. So they all have a three-dimensional shape to them. Looks like another silly alien, right? So you see that's where the pyramid comes from. If I take off this lone pair and add a fourth one with no lone pairs, you can see that it is tetrahedral. You see that tetrahedrals are not flat, right? It has this sort of shape to them, right? And there are tons of other shapes, like, you know, if I add lone pairs to this, you get seesaw, but we don't learn about all the other shapes. We're just sticking to the ones that we talked about, okay? And so I'm gonna do a couple more examples and then we'll end there. So give me just a second. Okay, so I'm not gonna do all of these examples, but the ones that I wanted to do right here is I'm gonna do CS2. So CS2 right here, hold on just a second. So we have a carbon, which has, so I'm gonna draw really, really small. So carbon, according to our periodic table, right here, it has 4. So I'm gonna draw 1, 2, 3, 4. We see that sulfur right here is in the 6th column. So I'm gonna do 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Okay, so we can see here that these are paired up already, and these are paired up, these are paired up, and these are paired up, and everything else is single. So we have to pair them up. So these single elements must be paired up. This is really tough. A lot of people do not draw this one correctly, but every single electron, the single electron needs to have a friend. So we can link these two, we can link these two, we can link this, and we can link that. So think about it. How many lines did we draw? We drew 4. Okay, so that means 4 lines have to show up in my drawing. So carbon's gonna go in the middle, right? The center atom is always the one that's, there's the fewest number. So carbon has to go in the middle. How many lines did I draw to one of these sulfurs? I drew 2 lines to one sulfur here, and I drew 2 lines to the other sulfur here. You can't leave it like this. You got to include your lone pairs. So I have 1, 2, 3, 4, 1, 2, 3, 4, right? So now let's think. Here's some questions that you have to consider. It says, how many atoms are bonded to the central atom? So how many elements, right, do we have atoms bonded to the center one? We have 2. This S and this S, 2, okay? On the center, so the central atom, that's the key word here, okay? Are there any lone pairs? So are there any dots around carbon? No, okay? So to no is then what shape? So you go back and be like, to no, it creates a straight line. So you would write that it's linear. So this is the thought process that you need to have in order to answer the question as to what shape it is, okay? One other example I wanted to do was this one, Br2O. So here, if you look, bromine is in the 7th column and oxygen is in the 6th column. Sorry, my circles are getting out of control. But so bromine, there's 2 of them. So I'm gonna go 1, 2, 3, 4, 5, 6, 7. I have another bromine, 1, 2, 3, 4, 5, 6, 7, and then I have oxygen with 6, 2, 3, 4, 5, 6. So remember here are lone pairs, lone pairs, lone pairs. You always have to draw your lone pairs when you're done with your drawing, so you just don't forget about them. So here's my single, here's my single, here's a single, here's a single. How we're gonna connect them? Connect here, connect here. So I drew a total of 2 lines, so I need to end my drawing with 2 lines. The one that goes in the center is the one you have the fewest amount of. So oxygen is going to go in the middle. I have bromine on the right. I have 1 line of bromine on the left. I have a bunch of dots. I have a bunch of lone pairs that I need to draw. So bromine had 1, 2, 3, 4, 5, 6. And this other bromine also had 6. But oxygen also had some, right? It has some here and here, right? So you have to include them. I have 4, so I do 1, 2, 3, 4. So now you answer the question. So here it's all about the center, the central, the middle element. How many atoms are bonded to the central one? 2. I have a bromine here and I have a bromine there. How are there lone pairs on just the center, the middle one? Yes, right? I have some here and here. So bromine obviously has lone pairs, but we don't care about them. We just care about the one in the middle. So the answer here is then yes. 2 yes, right? So you go and look, 2 yes is what shape? It becomes bent. So now I feel like we went through all the examples. Okay, so we'll do more practice in class. Awesome, pasa.